In our next session, we're going to be introducing the IS to IS routing protocol. On the screen, we have an amazingly scenic beach somewhere off the coast of Portugal. And I've managed to get in touch with some of my industry contacts to bring our next distinguished guest to the show. Talking about scenes, he's visited every continent in the world and seen some of the most beautiful sights that a man can see. So without further ado, take it away, David.
Today, let us take a look at another IGP. Not much is known about this rare, unusual link-state routing protocol. And in fact, this exceptional routing protocol is not often seen. If you have only enterprise networks experience, you might not have come across this interior gateway protocol at all. But it exists, and thriving in the service provider realm. This rare but distinguished protocol is called IS to IS. Just like OSPF, it forms neighbor adjacencies, builds a link state database, and runs the Dijkstra SPF algorithm to find the best path to each destination. However, whereas OSPF is a Layer 3 routing protocol using IP Protocol 89 as transport, IS to IS is directly encapsulated in Layer 2. Developed by the Digital Equipment Corporation and then later adopted by ISO when IP was not the leading protocol stack in operation, IS to IS was actually developed for the CLNS protocol stack. And that is why it's called IS to IS. Intermediate system to intermediate system. When IP became the prevalent protocol stack of choice, IS to IS was modified and evolved to also run on IP. This new protocol was called Integrated IS to IS, and it is this extraordinary routing protocol that we will be concentrating our attentions upon.
That is absolutely superb. But getting back to IS, we need to cover the network entity title, which is called the net address. So I have an animation that's going to introduce that to us, and then we're going to get on with some labbing. IS uses network entity title addresses, which we will call net addresses. And these are divided into 4 sections, but only the AFI and area ID portions are configurable. Now, the first of the 4 sections is the AFI, which is the address family identifier. If we are just using IP and we're not going to be using CLNS, then this is not significant for routing, but it is significant for other routers to be able to identify the area. When we look at the AFI of 49, then this is equivalent to the RFC 1918 private addressing scheme. Next up, we have the area ID, which is a variable length field between 0 and 12 bytes. When combined with the AFI, this identifies which area the router is in. Then we have the system ID, which is a 6-byte field. This value is not directly configurable under IS to IS. However, the system ID is derived from the system or router ID. If the router ID is configured, then this overrides the configuration under the system interface, and the router ID will be the system ID. And last but not least, we have the selector ID, which is a 1-byte field, which must contain zeros when a net is configured. This is not configurable and will always be 0, 0. As we've done with all of our previous sections, we're not going to cover all of the theory up front, but we're going to cover the theory as we go along. So I have a router. It's a plain vanilla router, meaning it's got no configuration on it whatsoever. And what I'm going to do, I'm just going to add a base config to the actual router, which I have in a notepad. Let me just copy and paste that in. And also what I will do, I will configure the system name. Excellent. So we're good to go. When we're doing the configuration of IS to IS, I will say IS to IS1, which is the process. And there are two sections that are configurable. The first is the area ID, which I will say is 49.0001. By default, IS to IS will not come up unless we actually add an interface. So we'll add the 2R2 interface and make it a point-to-point interface. Now, with regards to the net addressing, if we don't manually configure one, it will use the system address as its net address. And we can verify that if we run the show router ISIS1 hostname. And it said that the system address has to be a 6-byte address. It will add 2 zeros in front of each of our ones. So we will have 001, then 001, 001, and 001. That is our 1.1.1 address. It will just add 2 zeros in front of each section. But we will notice that it's actually separated into 6 bytes. So we can see 0010, 0010, sorry, 0010, 0100, and 1001, which is the same as our system address here. If we wanted to change this, we could actually use a bespoke net address. The way to do this, if I configured a router ID and I had a random one, I said, let's use the loopback address, 192.168.1.1. Then what would we expect our system ID now to be? Well, actually, it will still be the same because we need to restart the process. But as a guess, I would say it would be 192.168.001.001. That's what I'm expecting the system ID now to be. So 192.168.001.001. So let's shut down the process and start it back up again. And let's have a look at that. Show router ISIS1 hostname. Exactly as I said, 192.168.001.001. So this is just a brief introduction to the net addresses and how we could change first the area ID and also the system ID.